Okay, so let's begin with the final question of this whole paper. And over here, we are given the curve with this particular equation. And it also has point A and B lying on it. And then there is also a line which passes from point A and B. So in the first part, we are asked to find the equation of this line that is passing from A and B. So now to get equation of any kind of straight line, there are two things that we require. One is the gradient of that line, and the other thing is called the y-intercept of that line. So let us go ahead and first of all find what's the gradient of AB. So gradient of AB is equals to change in y upon change in x. So change in y, let's say we are considering this as the second point and this as the first point. So the change in y is -1 -2 divided by change in x is 2 minus 5. So this becomes -3 over -3. So this comes out to be 1. So we know that the gradient of this line AB is 1. So what's the equation of line now? It's y is equals to mx. So 1 into x is simply x plus c. We still have not got the y-intercept. So how can we get the y-intercept? By simply plugging in any kind of point that lies on the line. We are having two options. You can choose any one. I am simply go ahead and choosing the B point. So this becomes y is -1, c is 2 plus c. So c becomes -3. So what's the equation of AB? Therefore, or this implies, equation of AB line is y is equals to x minus 3. So that's the answer of first part of question 11. So I'll just label this over here on this curve. This is because this is written as x equals to y square plus 1. I'll also write this in the format of x is equal to y plus 3 is what we'll be getting. Right? So that's the equation of line. And over here, I'll also write this because I guess we'll be needing it for the next part. All right. So yeah, let's go ahead. The part B is asking us to find the volume of revolution when the region between the curve and the line AB is rotated about 360 degrees about the y-axis. All right. So for that, what we'll do is, first of all, let me get rid of everything else that we don't need. Okay. So now what we are having? We are having, first of all, this shaded region, which we are going to rotate about y-axis for 360 degrees. So for that, what will be the formula? The formula, so first of all, what we do is, first of all, we find out what is the area that we'll be getting over here. So that area would be nothing but, if I'm looking with respect to the y-axis, so this is the kind of region that we need to trap. So everything that is below the line, if we subtract from everything that is below the curve, if we subtract everything below the line from everything that is below the curve, if I cancel this out, I'll be left only with the shaded region. All right. And the formula for the volume that is generated if we rotate shaded region about y-axis for 360 degrees becomes pi integration of x squared with respect to dy. So that's the kind of equation that we'll be getting for line as well as the curve. So we know that, first of all, the x square for the line will be y plus 3 squared, and x square for the curve will be y square plus 1 whole square, right? So we need to find out what's everything that is below the line minus everything below the curve and multiply it with pi, right? So that will give us the volume of this shaded region. So let us go ahead and do this. So let me scroll down. All right. And the formula, as I mentioned, over here, the volume that will be generated will be pi, then integration of everything that is below the line, that is y plus 3 square dot dy minus pi integration of everything below the curve. So y square plus 1, I'll just get rid of this, the square of this dot dy. So that's it. If we are able to solve this, we are done. And what are the coordinates through which we'll be able to get the bounds? So the y value is going to go from -1 to 2, right? So we are going from -1 to 2. So that are the limits. And the value that we need to give, I guess, okay, they have not asked us to give it in the exact format, but yeah, that's something that we'll be doing. All right, we'll be getting the answer in the exact format. And the curve is having the bounds from -1 to 2, -1 to 2. I'll just again cross check that once. So yeah, -1 to 2 is what we are having. All right. So yeah, let's go ahead and solve this particular thing. Yeah. So therefore, my v is equal to pi integration of, if I open this bracket, it would be y squared plus 6y plus 9 dy minus pi. Obviously, the bounds are -1 to 2. Over here, it would be y to the power of 4 plus 2y squared plus 1 and then dy. So now this v, and therefore now we are doing integration over here. So pi, so over here it would be y cubed by 3. Over here it would be 6y squared divided by 2. So 6 by 2 becomes 3 and y is getting squared plus 9y. The values are going from -1 to 2. Then again minus pi. And now if we integrate this, this becomes y to the power of 5 by 5. Then plus 2 by 3 y squared, y cube, right? 2 plus 1 is 3. So yeah, 2 by 3 y cube plus y. And over here also, the values are going from -1 to 2. Now, simply if you just solve this in the calc, you will be getting the final value of v. You can just cross check that. I'm not going to do that calculation. You just need to substitute the values of 2 over here, then subtract it from -1, all right? And then do it again for that part. Substitute 2 first and take away the values of -1. And you will be getting the outputs of the first part and the second part. And once you will subtract it, the final value that you will be getting, if I just look into the final marking scheme, the value is coming out to be, what is the value? It's coming out to be 23 2 over 5 pi. So it's 23rd to 5th. So 23rd to 5th pi. So that's the value that you will be getting. And let's check what's the units over here. Okay, we don't have any kind of units in centimeters or meters or anything like that. So we can just consider this as unit cube. Unit cube. All right, so yeah, that's it. That's it for this whole paper, guys. And I hope that you understood all of these questions. In case of any kind of queries, you can again reach out to me on this number, or else you can comment it down in these videos and I'll just get back to you as soon as possible. Thank you.